Validity. Introduction. Now, having learnt the basic concepts of predicate logic, we can enter the heartland of logic. We can use our concepts to analyze why certain inferences seem correct and others don't. Why do we strongly believe that, quote, some days are rainy, unquote, follows from some days are rainy and windy? And even with no regard to what day, rainy, and windy mean. And why do we strongly believe that some days are rainy does not follow from some days are rainy or windy? What we are talking about here is the question of logical consequence and validity. A first-order formula of vocabulary L is valid if it is satisfied by every assignment and every structure for L. A valid formula expresses a general logical truth, something which is always true, whatever is the meaning of the predicate and constant symbols of the formula. Examples. Here are some examples of valid formulas of predicate logic. In each case, the proof of validity is easy. One takes an arbitrary model and an arbitrary assignment and shows that the assignment satisfies the formula in the model. Tautologies, that is, formulas that have the appearance of a tautology, although they are not propositional formulas, this is made exact in problem 200, are valid. Left parenthesis, A or B, right parenthesis, if and only if, left parenthesis, B or A, right parenthesis. A or not A. Not, left parenthesis, A or B, right parenthesis, if and only if, left parenthesis, not A and not B, right parenthesis. Not, left parenthesis, A and B, right parenthesis, if and only if, left parenthesis, not A or not B, right parenthesis. These last two are the so-called De Morgan laws. Left parenthesis, A implies B, right parenthesis, if and only if, left parenthesis, not A or B, right parenthesis. For all x, P0 of x, or not for all x, P0 of x. Here are some valid formulas related to equations. X equals x. If x equals y, then y equals x. Left parenthesis, x equals y and y equals z, right parenthesis, implies x equals z. Here are some valid quantifier statements. For all x, Pn of x implies Pn of y. If Pn of y, then there is an x such that Pn of x. For all x, Pn of x implies for all y, Pn of y. Logical consequence. Suppose A and B are first-order formulas of a vocabulary L. We say that B is a logical consequence of A if in any model M, every assignment that satisfies A satisfies B. Equivalently, A implies B is valid. Note, it can be proved that there is no mechanical method for deciding logical consequence. One has to be creative. Equivalence. Suppose A and B are first-order formulas of a vocabulary L. We say that A and B are logically equivalent if they are logical consequences of each other. Equivalently, A if and only if B is valid. Here is a table of simple equivalences. Not there exists XA, equivalent formula for all x not A. Not for all XA, equivalent formula there is an x such that not A. For all x, A and B, equivalent formula for all XA and for all XB. There is an x such that A or B, equivalently there is an x such that A, or there is an x such that B. There is an x, there is a y such that a, equivalent formula, there is a y, there is an x such that a. For all x, for all y, a, equivalent formula, for all y, for all x, a.